So far we've looked at a particular orientation of a parabola where it's opening upward and along the y-axis is the axis of symmetry. We've looked at two equations, the vertex being at the origin and the vertex being shifted off to h comma k. And we've seen these two equations, derived the first one and then showed how a shift or transformation results in the second one. Now what I want to do is look at three other orientations of a parabola. First, where again the axis of symmetry is along the y-axis but now shifted or opening downward. And this is going to look very familiar, I assume. But in order to reflect this downward, we can multiply one side of the equation by a -1. Okay, and that will reflect the graph and cause it to open downward. Now we could, in the past we've multiplied the x by negative, so you had a negative coefficient on the x squared term. In this case, because it's one term on either side, it doesn't matter which side the negative is multiplied to. You can multiply it to the left, or you could divide both sides by the negative and put it on the right. It doesn't really matter. It's arbitrary. And so we typically will put it now on the right side just to make this look a little neater. So you would have x squared equals -4ay. That would give you the parabola opening downward. And with the same shifting going on, if the vertex is at h comma k, then you would just have x minus h squared equals -4a times y minus k. So again, very similar, just with a negative on that side. And now, if we were to open this parabola to the right or to the left, you can imagine that the only real change is going to be the changing or interchanging of the variables. And so what we end up with is basically an inverse situation, although now we're not really concerned with whether this is a function and passes a vertical line test. We can actually allow it to fail the vertical line test because I'm not going to use function notation or represent this as a function. I just want the graph. I want an equation or a relation that represents the graph of a parabola that is now oriented horizontally. And so to do that, all we really need to do is switch the x and y values. We need to square the y and leave the x as the linear term, or the power of 1. So with a vertex again at 0, 0, you have y squared equals 4ax, and of course the positive will make this open to the right. And of course, if you were to shift this, the same shifting occurs. You end up with, if the vertex is at h comma k, then the formula that we're going to use is going to be y minus k squared equals 4a times x minus h. Okay, and then and you can obviously tell what the similar equations are going to be over on this side, where the parabola opens left. That's going to be with a negative coefficient, and so here you would have y squared equals -4ax, and down here it would be y minus k squared equals -4a times x minus h. So again, without writing all the details in there, it's pretty obvious how the relationships will play out. And so now we have equations that represent transformations of the graph, vertical, horizontal shifting, reflections, and the change in the a value on any of these will give us a change in the opening of the parabola, the width of the parabola. Remember, the directrix and focus are a units away from the vertex, and the width is dependent upon a. The width of that, the latus rectum, is 2 times a in either direction, so an opening of 4a total, okay? And so that a value will change the width, whether it's wider or narrower for that parabola. Your textbook has a couple of tables that summarize this information. You can find them on pages, where are they? 657, 659. So page 657 and 659 have some tables. In addition to these equations, they also give you coordinates for some of the points, which are nice. I'll just describe a little bit of that. I won't go through all the details of plotting those out, but for instance, in this situation here, if I wanted the coordinates of f, I would, what would I do here? I want to go a units over to the right, and so let's take this bottom where actually it's shifted as well. Whatever the coordinates of the vertex are, h comma k, I want to go a units to the right to find f, right? So f would actually be, it's h comma k, and then add a to the horizontal component. So it's h plus a comma k, right? That gives the focus another shift of a units right from the vertex. And the directrix, if I'm going to shift that also to h comma k, well, the k doesn't affect the directrix at all, the line going up and down, but the h value does, moves it left to right. And so in this case, it would be the equation x equals for a vertical line, and it's going to be whatever the h value is minus a, because we're going the opposite way to the left. So it'd be h minus a for the equation of the directrix, okay? And then of course the vertex is at h comma k. So, and you can make the corresponding adjustments for each of these graphs here, because everything is flipped around. The focus would be h minus a comma k, because now the focus is on the left and the directrix is on the right, and so the directrix would be x equals h plus a. And so you just make the corresponding adjustment to find the coordinates of those features of the graph, the vertex, the focus, the directrix. And you can do that for all four of these, and the two tables in the book kind of lay out the details of those.